Hello everyone. In this Labtube, I will solve an example for Gauss-Jordan elimination method. The question says, solve the system by Gauss-Jordan elimination method, and the system is given here. Okay, to apply Gauss-Jordan elimination method, what I need is an augmented matrix. I have to first check that the system is written in the standard form, meaning that each equation is written in a standard form and same variables are aligned. So this is the case, this is the case, this is the case, and then everything on the right-hand side also are constant. So I can make my augmented matrix here. So coefficients of x1 goes to first column, coefficients of x2 second column, coefficients of x3 goes to the third column, equalities turn into a line, and right-hand side goes there. Okay, that's augmented matrix. Then the second step is that I have to transform this matrix to its row-reduced echelon form. Okay, I have to use elementary row operations. And how I do this is that, okay, first look at the first column. Pick one of non-zero elements, if there is any one. So here there is one. I choose this guy. And pick one of them and use it or make it leading one. Means that first change it to 1, it's already 1. Then make everything else in that column 0. Okay, so it's 1. Then I want to make row 2, the first entry of row 2, 0. What I can do is I can multiply -3 to row 1 and add it to row 2. Okay, let's see what it is. So I have 1, 2, -1, -3. I'm not touching row 1. I'm not touching row 3. But row 2 is entry in row 2 minus 3 times entry in row 1. 3 minus 3 is 0. 6 minus 3 times 2 is 0. -2 minus 3 times -1 is 1. And -7 minus 3 times -3 is -7 plus 9, it's 2. This is very good. Now I made this column, this entry 0. I have to make this one also 0 by doing so. Let me go up there. So I can make this one 0 by multiplying row 1 by -2 and add it to row 3. So row 3 minus 2 times row 1. So I will keep row 1. I'm not changing that, so I write that. Row 2 is there. 2. And then for row 3, multiply row 1 by -2 added to row 2. So 2 minus 2 times 1 is 0. 4 minus 2 times 2 is 0. And 0 minus 2 times -2 is plus 2. And -2 minus 2 times -3, that will give me 6. And this is 4. That's very good. So I managed to make a leading one for the first column. Then next step is move to the column 2. Is there any element there that I can make it leading one? Okay, so this row, it already has a 1, so I exclude that part from row 1. from row 2 and row 3, both of them are 0. I can't make leading 1 out of 0. That means that I'm not going to have leading 1 for the second column. I have to move 1 further. Column 3, exclude the rows with leading 1, and then choose one of these as our next leading 1. So I'll choose this. It's already 1, and I can use it. Then go ahead and make other entries 0. So this is my leading 1. I have to use this to make this 0 and to make this 0. For that, I will start with row 1. If I add row 2 to row 1, then 1 plus negative 1 is 0. I will get rid of that negative 1. So I will have 0, 0, 1. First, I'm writing the rows that I'm not touching. For the row 1, I add this to that. 0 plus 1 is 1. 0 plus 2 is 2. 1 plus negative 1 is 0. 2 plus negative 3 is negative 1. Then the next step is make this other entry in the same column 0. So for that, what I need is multiply row 2 by negative 2, and then add it to row 3. So again, I'm not touching row 1. I'm not touching row 2. For row 3, I have to multiply row 2 by negative 2 and add it to this. This is 0 plus 0 is 0. 0 plus 0 is 0. Negative 2 times 1 is negative 2 plus 2. This is 0. And negative 2 times 2 is 4. Add to 4 is 0. Well, I'm done because I had 3 columns and I checked every one of them and made leading ones which were possible to make. So this is, in other words, this is row-reduced echelon form of that augmented matrix. Then the next step is that I have to decide, or I have to find the solutions. Before I go and do the next step, we can check something here. Now I have 1, 2 leading ones, and since the number of leading ones, which is 2, is less than the number of columns, which is 3, that means that I'm going to have infinitely many solutions. But how I'm going to find them is here. So when I find row-reduced echelon form, write it back in equation form, meaning that write an equation for each row which is non-zero. And we know that column 1 is the coefficients for x1, column 2 for x2, column 3 for x3, and after the line are the constants on the right-hand side. So basically, I will have 1 x1 plus 2 x2 equals to negative 1. And this guy is 0 times x1, 0 times x2, and 1 times x3 is 2. The last row, everything is 0. I don't need to write that. So when you change back to the equation form, what you need to do is solve each one of the equations for the leading variable, meaning that find variables with leading 1 as their coefficient and write them in terms of the other variables in the equation. In this case, leading variable is x1. I take everything else into the right-hand side. I get this. And I solve this one, x3 equals to 2. Well, I have value for x1. I have value for x3. What about x2? Note that x2 or column 2 doesn't have any leading 1. That means that x2 is going to be a free variable or a parameter t. Well, that's good because now I can put that into my equations and write x1 is negative 1 minus 2, x2. x2 I already know is t, so, and I write them in order, so x2 is t, x3 is 2. This means that the solutions are, which are infinitely many of them, are of this form. The first component is -1, -2t. The second component is t, and the third component is 2. Steps for Gauss-Jordan elimination method. Check the system is in the standard form, write augmented matrix, row reduce echelon form, change back to equation form, and solve the leading variables, solve the equations for leading variables. And then this is an example of that.